Hello and welcome all to another exciting video from Psychophilics. So in today's video lecture, we'll be talking about resting potential. Any idea what it might be? If you guessed that it's related to neurons, you would be correct. So let's take a look at it. Neurons are the functional unit of the nervous system. Neurons produce electric signals in order to facilitate the communication process between them. This communication is done using electric impulses, also called as action potential. All processing of information is due to the ability of our neurons to fire. Before we begin with the process, let's take a look into the diagram of a neuron to understand its parts.
Every neuron is usually in a resting state. All neurons are covered by a membrane. This membrane separates the extraneuronal space from the intraneuronal space. The extraneuronal space is all the space that is outside the neuron. The intraneuronal space is all the space that is inside the neuron. When the neuron is at rest, it maintains a difference in electrical charge between the extraneuronal and intraneuronal spaces. This difference is called the resting potential. This resting potential keeps the membrane in what we call a polarized state. This resting potential of the neuron is approximately minus 70 millivolts. During the resting state, sodium ions are highly concentrated outside the membrane, which is the extraneuronal space, than inside, which is the intraneuronal space. On the other hand, potassium ions are highly concentrated inside the membrane than the outside. This difference is maintained by many ion channels that usually remain closed, preventing the free flow of ions through the membrane. The ion channels only open when the neuron fires an action potential. An important part of the membrane to note is the sodium-potassium pump. This pump keeps expelling free sodium ions from inside to outside the membrane, and at the same time takes in two potassium ions from outside to inside. This mechanism plays an important role in maintaining the resting state. The inside of the cell is negatively charged and the outside of the cell is positively charged. If an electrical signal excites a neuron by taking its resting potential from minus 70 millivolts to minus 55 millivolts, the neuron will lose the resting potential, resulting in an action potential. This benchmark of minus 55 millivolts is called the threshold potential. In simple terms, the threshold is the electrical potential at which a neuron loses its resting state and moves to a firing state. It becomes now what we call as depolarized. Moving on to EPSP and IPSP. The conductance of an action potential in postsynaptic neuron is based on the summation of what we call EPSP and IPSP. So what are EPSP and IPSP? If the electrical signal from the presynaptic neuron is sufficient enough to raise the membrane potential above the threshold of minus 55 millivolts, the postsynaptic neuron is going to fire, or in other words, initiate an action potential. This is called excitatory postsynaptic potential, or EPSP. On the other hand, if the electrical signal from the presynaptic neuron stops a postsynaptic neuron that is already firing from further firing, or if it prevents the initiation of a new action potential, it is called an inhibitory postsynaptic potential, or IPSP. It is critical to note that EPSP will always depolarize the postsynaptic neuron, thereby making it fire, whereas the IPSP will always keep the membrane potential more negative inside to maintain the resting state. Thus, all IPSPs prevent firing.
So now that we've come to the end of this video, let's have a short summary. Neurons are the fundamental units of our nervous system. They communicate with each other through electrical signals. Every neuron has a resting state and an active firing state. The resting state is maintained by the presence of membrane potential. A signal moves on the threshold of minus 55 millivolts breaks the resting state, resulting in an active state or a polarized state. Further, Any signal increasing the probability of firing of a neuron is an EPSP, and any signal decreasing the probability of firing of the postsynaptic neuron maintains the resting state. This is called an IPSP. In the next video, we will discuss the action potential. Hope this video helped. So if you liked our content, like, share and subscribe, and thank you so much for watching.